Okay students, now we are looking at the second step. As we said that biliverdin has been formed from the heme. Now what is the second step? This biliverdin basically undergoes reduction. So for reduction we need an enzyme, and that enzyme is NADP reductase. Okay, so what happens, we need hydrogen to add for the reduction. So you need a substance which is NADPH, and NADPH will deliver its hydrogen to biliverdin and will be converted into NADP plus. So we need NADP reductase. This NADPH will be converted into NADP plus and H positive, and there will be reduction, and this biliverdin will be converted into a red orange substance which is referred to as bilirubin. Do remember the colors of the products, these are very important. I'll tell you why. So this is red orange in color. So bilirubin is basically red orange in color, and it is the reduced product of biliverdin. Okay, now what is the main point about this bilirubin? This bilirubin is basically unconjugated bilirubin. Unconjugated bilirubin, it means it has nothing attached to it, it has no extra molecule attached to it. There is also conjugated bilirubin which will be formed later. For this time, just remember that this is unconjugated bilirubin. Unconjugated bilirubin is insoluble in water. The most important point of whole lecture, it is insoluble in water, and it is soluble in fats or alcohol. Okay, so this bilirubin is insoluble in water, it is soluble in fats, and it is soluble in alcohol. It means that this bilirubin cannot travel into the blood. Till now we are present into the macrophage of liver or spleen. This RBC is present in the macrophage of liver and spleen. We have formed heme, we have formed biliverdin, we have formed bilirubin. This bilirubin still into the macrophage of liver and spleen, but as it is insoluble in water, and blood is 55% plasma, out of 55% of plasma, 90% of plasma is water. So this bilirubin cannot travel in blood. So we need some carrier to transport this bilirubin through the blood into the liver, into the hepatocyte. Okay, so it is present in the macrophage cell, but we want to transport it to through the blood into the hepatocyte of liver. Okay, so what happens that this bilirubin is combined with albumin to form bilirubin albumin complex. So bilirubin basically transports albumin basically transports bilirubin through the blood. Okay, so this albumin, and do remember this bilirubin is bound to albumin through a non-covalent bond. It is not a covalent bond, because if it is a covalent bond, it will be permanent attachment to albumin. So it's a non-covalent bond that whenever the bilirubin albumin complex reaches the hepatocyte, bilirubin easily separates from the albumin, and then bilirubin enters into the hepatocyte of the liver. It is the macrophage of liver or spleen. We are entering the bilirubin, we have made the bilirubin enter into the hepatocyte. Okay, so basically what happens that there are some anionic drugs, okay, like salicylates, like sulfonamides. These are the anionic drugs. What do these anionic drugs do? These anionic drugs basically compete with bilirubin for the binding site present on albumin. Suppose this is albumin, and this albumin has binding site on which bilirubin binds. Okay, this is albumin. So whenever the drugs are given like sulfonamides or anionic drugs like salicylates, then the drugs and bilirubin combine for this binding site present on the albumin. Then what happens that these anionic drugs displace this bilirubin from the albumin, and then bilirubin enters into the blood. Okay, so what happens that these drugs are here and the bilirubin is here. Now what does this bilirubin do? This bilirubin starts depositing into the central nervous system, basically in basal ganglion. What happens in children, that if there is excess amount of bilirubin deposited into the central nervous system, then the condition is termed as the connectress, and it's a very severe condition that leads to very severe symptoms, like there are hearing loss, there is vision and tooth disabilities, there is also a mental retardation. Okay, so this is referred to as connectress. So what is the effect of anionic drugs? That this displaces the bilirubin and can lead to connectress. Okay, and connectress can lead to mental retardation or hearing loss and vision and tooth loss also. So this is basically the effect on the effect of drugs. So the second step is the conversion of green colored bilirubin into the red orange bilirubin. This bilirubin is unconjugated, it is insoluble in water, and it is soluble in fats and alcohol. So we need some medium to transport this bilirubin from macrophage of liver or spleen into the hepatocyte of liver or spleen. So what happens that this bilirubin binds to albumin, form bilirubin-albumin complex. It's a non-covalent bonding. So as it reaches the hepatocyte, the bilirubin separates from the albumin and enters into the hepatocyte. We are going to look at the third step. It was the first step, it was the second step, and now we are going to look at the third step. So as we discussed earlier that bilirubin-albumin complex was formed in the plasma, then what happens that this bilirubin needs to be transported into liver. As you know that this bilirubin is unconjugated, it is fat soluble, so it can easily cross the cell membrane of the liver, because cell membrane is also made up of phospholipid bilayer, so it can cross. But the problem is that this bilirubin is a large molecule and a polar molecule. So as you know that for large and polar molecules, we have only one kind of transport mechanism, which is facilitated diffusion. So we need some kind of carrier protein to transport this bilirubin into the liver from the plasma, and that plasma protein is ligand. Okay, so with the help of this plasma protein, this bilirubin is transported into the cell. Okay, so this is basically a type of a facilitated diffusion. This is basically a type of a facilitated diffusion. So bilirubin enters into the liver with the help of this ligand protein. So why do bilirubin enters into the liver? It enters into the liver for the most important function of liver, which is conjugation. One of the most important, which is conjugation. What does the liver do? Whenever the bilirubin enters into the liver, suppose it has entered into the liver, then what happens that two molecules of it is conjugated, means we have to make it a conjugated means to unite. We have to add some molecule into bilirubin. So what is that molecule which is added into bilirubin? That is that the two molecules of UDP glucuronic acid, we have two molecules of UDP glucuronic acid. UDP means uridine diphosphate. As you have ADP, ATP, adenine diphosphate. Similarly, we have two UDP glucuronic acid. This UDP glucuronic acid is separated into two UDP molecules and two molecules of glucuronic acid. Okay. Then these two molecules of glucuronic acid is basically added into this bilirubin. Okay, and this process again occurs with the help of an enzyme which is UGT. Okay, and what does this UGT stand for? This UGT stands for UDP glucuronosyl transferase. UDP glucuronosyl transferase. So this glucuronic acid is basically added into the bilirubin to form the conjugated bilirubin. So 2-UDP glucuronic acid is basically a glucuronate donor, glucuronic acid or glucuronate donor to form the conjugated bilirubin. And now what are the characteristics of this conjugated bilirubin? The most important one is it is soluble in water. As it is soluble in water, so it can flow into the blood. It can easily go wherever the blood goes. It can go to kidney. Okay, so the most important point is that it can go to the kidney. It can be filtered through the kidney. Okay, so this is the most important point. Now this conjugated bilirubin enters into bile. Okay, as you know, liver secretes bile. Okay, so this conjugated bilirubin enters into the bile, which is basically secreted by liver. So and then enters with the help of MRP2 protein. There is a protein again over here, MRP2, which is a carrier protein, but this time it is not facilitated diffusion. It is active transport. Why it is active transport? Because bile always contain conjugated bilirubin. So the conjugated bilirubin is already present in bile in the excess amount, while this liver is containing the unconjugated bilirubin, which is converted into conjugated bilirubin. So bile has higher amount of conjugated bilirubin because it contains only one type of bilirubin, which is conjugated. So that is why there is active transport occurring from liver into the bile with the help of this MRP2 protein. Okay, so active transport occurs and this bilirubin, conjugated bilirubin, becomes the part of bile. So do remember, bile always has conjugated bilirubin. and there is facilitated diffusion when bilirubin is transported into the liver. There is active transport when the conjugated bilirubin is transported into bile. Do remember one more point, that this bilirubin and this biliverdin, they are collectively referred to as bile pigments. Why are they called pigments? Because they give color. Biliverdin is green in color, bilirubin is red orange in color. So these are called as the bile pigments. Okay, and this bile, where does this bile go? You all know that this bile is stored in gallbladder. Okay, so this is basically the third step, that there is bilirubin albumin complex present in plasma. Bilirubin is large and polar molecule, although it is fat soluble, so it enters into the liver with the help of facilitated diffusion with the help of ligandin carrier protein. 2-UDP glucuronic acid, 2-UDP glucuronic acid transfers 2 molecules of glucuronic acid into bilirubin, makes it a conjugated bilirubin which is water soluble. This conjugated bilirubin enters into the bile with the help of MRP2 protein, which does the active transport of conjugated bilirubin into the bile. This bile is then stored into the gallbladder. And also remember the most important points from here. Difference between, you must know the conjugated and unconjugated bilirubin. You must know this UGT enzyme which is responsible for the addition of glucuronic acid into bilirubin, and you must know where is facilitated diffusion occurring and where is active transport occurring, all that steps. Okay.